Welcome to another video from ExplainingComputers.com. This time it's my ranking of the top 5 new single board computers 2024. As in previous years, the list will only include boards which have launched and which I've reviewed on this channel in the past 12 months. And here this means between the 1st of November 2023 and the 31st of October 2024. Before we begin, I think it's worth reflecting on how the SBC marketplace has changed over the past few years. Not least, many new ARM boards now cost over $100, the price of x86 mini PCs has fallen dramatically, powerful microcontrollers are now SBC alternatives for some projects, and low-cost RISC-V hardware has started to become available. As a result, whereas in the past I used to review pretty much all new single-board computers, I'm now far more selective, and generally only review boards which I think are cost-competitive options for makers and enthusiasts, or which represent major innovation. As a result, over the past 12 months, I've chosen to review 8 new single-board computers, all of which I will mention in this video. However, I've also seriously considered reviewing 9 others, and so before we move on to the top 5, I thought you might like to know what these boards were. The first of the boards I've noted but not reviewed in the past year is the Lichee Panda Mu. This is an x86 compute module with an N100 processor, 8GB of RAM and 64GB of eMMC flash storage. As we can see, the Mu has lots of different carrier boards available, so supporting a wide range of applications. It's also priced from $185.90 when purchased with a basic or light carrier board and heatsink, and should be excellent for a range of industrial applications. However, for enthusiasts and makers, more cost-effective N100 systems are available. Also in the past 12 months, we've seen the launch of the Armstrong SIG 7 and the Banana Pi BPI M7. I mention these together as they are in effect the same hardware with a different name. The boards are based on an octa-core RK3588 system on a chip and so are powerful ARM boards. But the prices, starting at, for example, $165 for a SIG 7 with 8GB of RAM and 64GB of eMMC flash storage, do not make these boards competitive options for many enthusiasts and makers. Moving on, we get to the Orange Pi 5 Max, which is also an RK3588 based SBC, but with the price here currently starting at $113.99 for an 8GB model. As we can see back on the Orange Pi page, there really is a lot to like about this board, including 2 full-size HDMI connectors and underneath a 2280 NVMe M.2 connector. Last year, the Orange Pi 5 family was number 2 in my list of the top new single-board computers 2023. And the Orange Pi 5 Max is almost certainly the best RK3588 board that I've yet to feature on the channel. Next, we come to the Radxa Neo 12L, a new ARM-based SBC based on the MediaTek Geno 1200 system on a chip, with 4 2.2 GHz A78 cores and 4 2 GHz A55 cores, along with a 4-TOPS MPU. As the application scenarios listed here on its web page signal, the board is focused on the industrial and IoT marketplace, although a model with 8GB of RAM and 128GB of onboard flash storage is currently priced at just over $120 on AliExpress. Staying with Radxa, I've been very tempted and remain tempted to take a look at their new ROC 2A and ROC 2F. Based on a Rockchip RK3528A system on a chip with 4 A53 ARM cores, these boards are currently priced on AliExpress at $20.40 and $15.34 respectively for 2GB models. And with appropriate software support, these could be great project boards. Finally, we come to a couple of RISC-V SBCs, the first of which is the Milk-V Mars. And whilst this is certainly not the first credit card size RISC-V board, it is an interesting piece of hardware based on a Star5 J87-110 system on a chip as used in the excellent Star5 Vision 5.2. Also from Milk-V we have the Jupiter, which is a mini ITX RISC-V SBC based on either a K1 or an M1 SpaceMIT system on a chip. Here availability has been a major constraint, but I'm pleased to report that I've now managed to purchase a Milk-V Jupiter which arrived yesterday, and I plan to use it in an Explaining Computers build video in a few weeks' time. Greetings! Just before we get to my top 5, I thought you might like to see the 3 new SBCs that I've reviewed in the past year but which did not make the list. Starting with the largest, what we have here is a Radxa X4, which is an x86 SBC with an Intel Celeron J4125 processor under this very quiet fan. The board's available with 2, 4 or 8 GB of RAM and with or without eMMC flash storage. This particular one has got 4 GB of RAM and no eMMC, and it cost me $52 plus an extra $9.90 for the cooler. Underneath, if we just flick it over, we find we have got an M-keyed M.2 slot, and this will take a 2280 NVMe SSD. Meanwhile, on the top of the board there's another M.2 slot. This one is E-keyed to take a wireless module. The board has also got an onboard RP2040 microcontroller as well as 2 full-size HDMI sockets. Finally, software support is excellent, as being an x86 computer, it can run Windows and any Linux distro. Moving on, the Orange Pi Zero 2W has got an all-winner 8618 system on a chip with 4 1.5 GHz A53 ARM cores. There we are, we've got the system on a chip the right way up. And on an Orange Pi Zero 2W, this can be coupled with 1, 1.5, 2 or 4 GB of RAM, with this board having 4 GB and costing me $31.99. We also get onboard Wi-Fi and Bluetooth, USB-C power and data, a mini HDMI connector around there, and we've also got header pads for 40-pin GPIO, and they do supply a GPIO connector which you can solder on if you wish. Finally, there is down here a 24-pin function interface, and this allows a daughter board to be mounted with more connectivity, including 2 more USB 2 ports, 100 megabit Ethernet and composite video. When it comes to software, a number of operating systems are available, including a minimum install of Android and Orange Pi OS. The latter was last updated in July 2024 and is now much improved and more stable compared to when I first ran it in my initial review. Finally, we have the Radxa Zero 3W, which is available with between 1 and 8 GB of RAM and up to 64 GB of eMMC. And here our board has got 2 GB of RAM and 16 GB of eMMC, for which I paid $33. The SoC is a Rockchip RK3566 with 4 1.6 GHz A55 cores, so this is a more powerful board than the Orange Pi Zero 2W we just looked at. We also get Wi-Fi 6 and Bluetooth 5.4, once again USB-C connectors for power and data, but here micro HDMI. Finally, on the software front, the officially supported Linux distro from Radxa is Debian. However, there's now also a rather good Ubuntu image available from the Ubuntu Rockchip project, which is now my recommended distro for this board. Well, you now know the boards I've discounted, and we've arrived at my top 5. And here at joint 4th I've placed the Banana Pi BPI F3 and the Siped Lichee Pi 3A. These are RISC-V computers, so intended for RISC-V pioneers and developers, and are both based on an octa-core SpaceMIC K1 system on a chip, which has got 8 1.6 GHz x60 RISC-V cores. As a result, both of these boards offer pretty much identical performance. This particular Banana Pi BPI F3 cost me $88.83 and has got 4 GB of RAM and 16 GB of eMMC flash storage, although models are available with up to 16 GB of RAM and 128 GB eMMC. Meanwhile, this Lichee Pi 3A cost me $99 and has got 8 GB of RAM and 32 GB eMMC, although a 16 GB RAM model is also available. Both boards also offer great connectivity, with the Banana Pi having underneath here a 2280 PCIe M.2 slot and on the top a mini PCIe connector. Meanwhile, the Lichee Pi 3A, if we look underneath here, has got two 2280 PCIe M.2 slots. And in my testing, both of these boards have worked well with not just NVMe SSDs, but also with this M.2 PCIe to SATA adapter, which offers all kinds of storage possibilities. And indeed, I've experimented using the Banana Pi BPI F3 to build a RAID NAS, which worked very well and signalled how in 2024 RISC-V became a competitor to ARM and x86 when building end-user storage solutions. When it comes to desktop computing, both boards run Bamboo OS, which is an Ubuntu-based distro from SpaceMIT that is specifically tailored for boards that use their RISC-V processors. Performance in Bamboo is very stable, if sometimes a little sluggish, although 1080p streaming media playback is pretty decent. On the Lichee Pi 3A, I've also successfully run Fedora. And in 2025, I expect more and more operating systems to become available for these and other RISC-V SBCs. Next, at number 3 on my list, we have this, the Odroid M1S from Hardkernel. And I don't know why, but I really like this SBC. Although I guess it's because you can buy a kit that contains a board like this one with 4 GB of RAM, 64 GB of eMMC, a case and a power supply for $49. Or you can pay $59 for an 8 GB model. But either way, you can get everything you need for old school SBC prices. In case you're wondering, the SoC under this supplied heatsink is a Rockchip RK3566 with 4 A55 cores clocked at up to 1.8 GHz. And we also have, if we just flick the board around like that, we also have full-size HDMI, and underneath we have got an M.2 slot that can take a 2280 NVMe SSD. When it comes to software, the board arrives with an OS installer on its eMMC. And this means you don't need to use another computer to set things up, with the available options being to install Ubuntu or Android. The former is currently version 20.04, which is only supported to April 2025 and has no GPU acceleration, so streaming media playback in a browser is terrible. However, 1080p streams fine in Android, although please be aware that this is a lower priced SBC for enthusiasts who are prepared to invest time experimenting with software. Well, it's now getting very exciting as we've reached number 2, which is this, the Radxa X4 ITX. As the name suggests, this is a mini ITX SBC, and it's got an RK3588 system on a chip under this rather large cooler, and this means we've got 4 2.4 GHz A76 ARM cores, plus another 4 1.8 GHz A55 cores. The board's available with between 4 and 32 GB of RAM, with this one having 8 GB and costing me $124. I rate this SBC very highly because it allows the construction of an ARM desktop or server computer in a Mini ITX or other standard PC case, with everything powered by a standard ATX power supply. Connectivity is excellent, including 2 full-size HDMI connectors. Down here, we've also got 2 2.5 gigabit Ethernet ports, and we look at the top here, we have got an M.2 slot, and this is a 2-lane PCIe 3.0, here fitted with our system drive. In addition to loads of USB, camera, display panel and other connectors, we also get an E-keyed M.2 connector for a wireless module if required, and very significantly, down here we've got 4 SATA ports. So, like the RISC-V boards we saw earlier, there are fantastic storage solution possibilities. Earlier this year, I used this board to build my first Mini ITX ARM PC in an InnoWin shopping case. The RISC-V ITX has 8GB of eMMC flash storage on which a system called Ruby OS is pre-installed, and on first boot this can be used to easily install a main operating system. Initially, I used a Debian image from Radxa, which comes with a KDE desktop and works very nicely. However, I later migrated to Ubuntu, making use of an image from the Ubuntu on Rockchip project from Joshua Rake. And this turns the RISC-V ITX into an absolutely excellent ARM desktop PC, including solid 4K streaming media playback. So, what's my top new SBC of 2024? Well, it's this, the Radxa X4, which is an x86 SBC with an Intel M100 CPU. Here it's fitted in the open heatsink case in which I use it, although here's a shot of the bare board, which, as we can see, has got a form factor that's very close to a Raspberry Pi. The X4 is available with 4, 8 or 16 GB of RAM and with or without 16 GB of onboard flash storage. However, mine has got 8 GB of RAM and no eMMC and cost me $82.66 plus $15.28 for the heatsink, which, as you can see, is under the board because the M100 processor is mounted under the board. And because this board doesn't have eMMC, I did have to add an NVMe SSD, a 2230 NVMe SSD here, but even so, this is a cost-effective M100 system that's become a go-to SBC that I use to help me make videos and to do other things. Last year, it was very much a Raspberry Pi 5, now in this Argon Neo 5 case that became a new working tool. But this year, it is very much the Radxa X4. On the downside, just like the Pi 5, the X4 does have micro HDMI connectors. But we do have a 3.5mm audio jack, as well as 10 gigabit USB 3 ports and 2.5 gigabit Ethernet. The M100 CPU also offers us 4 Intel E cores, clocked at up to 3.4 GHz, along with Intel UHD graphics. So, this SBC delivers great performance, and just like all M100 computers, can run Windows, Linux and any other x86 operating system. As you may know, if you saw my initial review, I did initially have some issues with cooling, which were fixed by adding a copper shim and disconnecting the fan for silent operation. And I also now usually use the board with this piece of black plastic card added, which offers a lot more protection for this most excellent M100 SBC. And so there we are, my top 5 new single board computers 2024. But what do you think of this list? Would you have different computers on it? Would there be SBCs that I didn't review and I mentioned earlier, or would there be boards I've missed entirely? Please let us all know down in the comments section. But now that's it for another video. If you've enjoyed what you've seen here, please press that like button. If you haven't subscribed, please subscribe, and I hope to talk to you again very soon.